Before understanding what light is, we first need to know the two basic units that make up almost everything around us: waves and particles.
Waves are all around us, from the sound we hear to the earthquake that caused us trouble. But what makes wave a wave? A wave transports energy from one place to another without transferring the matter of the medium.
But what about particles? Particles are the basic units of matter. Particles can be atoms, ions, or molecules.
Now that we've understood what wave and particles are, let's find out whether light is a wave or a particle. For this activity, we need two lasers of any color, then intercept them.
If light is a particle, the crossing light particles will collide with each other and reflect in other directions, like this. This will cause the laser beams to be reflected into many other directions, but in this case, we did not see any reflections of laser beams. This supports the idea that light is a wave and not a particle. We've come up with an activity to see the phenomenon of light diffraction. It is very simple and easy. You just need a laser pointer and a smartphone. All you need to do is to shine the laser to the edge of your phone's screen protector. The diffraction pattern will project at the screen. This is what we have.
We used a short-sighted glasses to spread the laser beam. For this experiment, we need a very symmetrical three-dimensional object, so we used a small spherical ball bearing. Can you see the bright spot at the center of the shadow?
The bright spot in the middle of the shadow is called the Poisson's spot. Light does not pass through the spherical object. Instead, light bends around the spherical object and overlaps in the exact center. This phenomenon is called diffraction, something that waves can do but particles can't.
Wow, that's really cool. Is that fair to say that light is a wave?
Oh, hell no!
Before jumping to conclusion, let's carry out a few more experiments to identify the behavior of the waves.
We need a container, cornflour, highlighter and water. Mix them up together and you'll get your own glow-in-the-dark liquid. We will be shining them with different colors of lasers. And lights off.
Why does blue laser charge the liquid, but red and green laser doesn't?
The reason why the blue laser is able to make the liquid glow is because it has higher momentum than both red and green lasers. Momentum is the amount of movement of something. This experiment proves that light is a particle because anything that has momentum consists of particles.
This is another simple activity. All we need to have is a red laser, a green laser, and anything that is bright and pink in color. So first, let's switch off the light. Now I'm going to shine the red laser onto the bright pink object. And as we can see, the red laser remains red. Now I'm going to shine the green laser onto the bright pink object. And as we can see, the green laser turns orange in color. The green laser does not magically turn its color into orange. The reason why it is orange is because the green laser has enough momentum to charge the fluorescent pigment in the bright pink object and make it glow, whereas the red laser doesn't. The results of experiment 1 shows that light is a wave. However, the results for experiment 2 shows that light is a particle.
Wait a minute!
How can the results of both of these experiments contradict each other? Well, this gives rise to the wave-particle duality.
Wow!
The wave-particle duality states that light can either be described as a wave or a particle. So the real question is, what actually is light? Well, light is a wave and a particle.
Thanks for watching.
Stay home.
Stay safe
And stay curious.
Bye!